Okay, for this video we're going to be looking at solving equations, specifically one-step equations, and then in a few days we're going to look at solving equations, but it'll have 2 steps. But today just 1. So first of all, an equation must always be balanced. When we do something to one side, we must do the same thing to the other side of the equal sign. So when we have an equation, we can separate our equation by an equal sign. So we're going to have something on the left side, we're going to have something on the right side. Anything we do on one side, you have to do the same thing to the other. Okay, equations want to stay balanced, meaning anything you do on one side, you have to do on the other to keep it balanced. To solve an equation, you want to get the variable alone on one side of the equal sign. So again, when we're solving an equation, we want to isolate the variable, get it by itself, make it all by itself. So we do this using something called inverse operations. So inverse operations. Inverse operations are operations that undo each other. So they're operations that are opposite each other. So again, if I'm thinking inverse operations, I'm thinking opposite. So again, to solve an equation, we want to get the variable by itself on one side or isolate it. And to do that, we'd use something called inverse operations. And let's see what those inverse operations are. Okay, it's real simple. Inverse operations. So we can see if our operation is addition, our inverse is subtraction. If our operation that the equation is telling us is subtraction, our inverse is addition. If our operation the equation tells us is multiplication, our inverse is division. And if the equation tells us division, we're going to use multiplication to help solve. So again, inverses mean opposite. We're using opposite operations or inverse operations in order to solve. So let's look at example A here. Example A is x minus 8 equals 2. X minus 8 equals 2. Now, in order to solve this, I'm going to use inverse operations or opposite. So I'm going to think about what the equation's telling me, and I'm going to do the opposite of it to get that variable by itself. So for letter A, it's saying x minus 8. Again, we want to get that x by itself. So I'm going to think of, well, okay, my operation is subtraction. What's the opposite of subtraction? Addition. So if I'm adding on the left side of our equal sign, I have to add on the right side of equal sign to keep it balanced. Now I have to think, what am I going to add by? Well, I want to get the x by itself, so I have to get rid of this 8 here. So I'm going to add by 8. Add by 8. Okay? So if I have a negative 8 or a minus 8 plus 8, those are going to end up canceling out. Those are going to cancel out and equal 0. So on the left-hand side, I'm just left with x. And then I have my equal sign. And then on the right-hand side, I have 2 plus 8. 2 plus 8 is 10. So I think that my solution is x is equal to 10. Now, I can check that. And checking is something I should be doing to start off to make sure I'm doing this correctly. What I'm going to do is I'm going to plug this 10 back into my original equation. So my original equation was x minus 8 equals 2. I'm going to take this 10 and I'm going to plug it in here for x. Because x is supposed to be 10, so if I plug this in, everything should work out. So I should have 10 minus 8 equals 2. On the left-hand side, 10 minus 8 is equal to 2. I bring down the 2 from the right-hand side. Does 2 equal 2? Yep. So I know that x does equal 10. I know that this is the correct answer there. Let's look at example B. Example B is q plus 16 equals negative 20. Again, the operation it's telling me is addition, so I'm going to use my inverse of that, or opposite of that, to help solve. So I'm going to subtract. And if I subtract on that side, I need to subtract on this side of the equal sign. And what am I going to subtract by? Well, I need to get rid of this plus 16, so I'm going to subtract by 16 to get rid of it.
Deb Wilson, please dial 594.
So on the left-hand side, I have a plus 16 minus 16. Those are going to cancel out, and I'm just left with q. I bring down my equal sign. On the right-hand side, I have negative 20 minus 16. Well, it's negative and I have subtraction, so I want to turn this into adding by the opposite. Negative 20 plus negative 16. I can add those two together because they're both negatives, and I end up with 36 negative. So I think Q is equal to negative 36. Now I want to go through and I want to check it. So I'm going to plug my original equation, Q plus 16 equals negative 20. I'm going to actually plug my 36 in for Q here. So negative 36 plus 16, and I want to see if negative 36 plus 16 is going to equal to negative 20. So I look at this side. I actually have to go through negative 36 plus 16. Well, they have different signs, so I would do absolute value and subtract. 36 minus 16 is 20. And since 36 is bigger and it was negative, my answer is negative. So looking here, negative 20 is equal to negative 20. That works, meaning that's the correct answer. Let's look at another example. Example C, 3x is equal to 20. So in order to solve this, I need to think, what operation is this telling me? Well, if there's no symbol between the 3 and the x, that's telling me multiply. So I need to do the opposite of multiply to get my x by itself, which is divide. So I'm going to divide on both sides. Well, what am I going to divide by? I'm going to divide by 3. I'm going to divide by 3 here. So divide by 3, divide by 3. Again, that's going to cancel these out. 3 divided by 3 is just 1. So on the left-hand side, I'm left with 1x, or just x. I bring down my equal sign. On the right-hand side, I have 21 divided by 3, which is 7. So I think x is equal to 7. Now I want to go through and do my check. Okay, I'm going to plug it in. 3x is equal to 21. For x, I want to plug in 7. So 3 times 7 should equal 21. 3 times 7 is 21. Does 21 equal 21? Yep. So I know that that must be good. Again, right now we should be going through the checks to make sure we're doing this right. Let's look at example D. Example D says C over, or C divided by, negative 6 is equal to negative 1. I can go ahead and think, okay, I have division. The opposite of division is multiplication. So if I multiply on the left to get C by itself, I need to multiply on the right. What am I going to multiply by? Well, if I'm dividing by negative 6, I need to multiply by negative 6. Those are going to cancel. So on the left-hand side, I'm left with C. So C equals, on the right-hand side, I have negative 1 times negative 6. 1 times 6 is just 6, and since they have the same sign, my answer is positive. Positive 6. Now I need to go through and do my check. So my original equation was C over negative 6 is equal to negative 1. I'm going to plug in 6 as C. So I have 6 over negative 6 equals negative 1. 6 divided by 6 is 1. Because they have different signs here, it's going to be negative. And I can see it equals to negative 1 on the right-hand side. So that's good, meaning that's good.